Okay, let's say a, b, c, and m are integers with certain conditions, like m should be positive and d is the greatest common divisor of c and m, and ac is congruent to bc modulo m. Then a is congruent to b modulo m over d. So it looks like we can cancel out on both sides. Looks like a division is working with respect to c, but when you do that, you have to also divide this modular m by c, by d actually. Then one minor condition here looks like m over d should be an integer, right? So one clear thing is d must be a divisor of m, and that's why one of the reasons we have this condition here. D is a greatest common divisor of c and m. So please remember this theorem. Even we are not using this one that much in our class, but this is very complicated, right? So please look at it carefully. Let's prove it. Prove it's not that much difficult. Okay, our assumption was AC is congruent to BC modulo M. Then by the definition of congruency, M is a divisor of AC minus BC. So when you factor out C, we can say M is a divisor of C times A minus B. Right? Just research for that. Then the meaning of this is the C times A minus B or AC minus BC can be written by M times K for certain integer K. Right? So K is just fixed by the condition of A, B, C, and M. Right? Okay, but anyway, the C times A minus B is multiple of M. That's sure thing. Then let's divide on both sides by D, which is the greatest common divisor of C and M. Then we can write down that with this way, right? C over D times A minus B equals M over D times K. Then one thing is clear. C over D is an integer because D is one of the divisors of C. Right? And M over D is also an integer because D is a divisor of M. Then looks like M over D is a divisor of this whole thing, right? C over D times A minus B. So in general case, we don't know whether M over D is a divisor of A minus B, but another extra condition for D is the greatest common divisor of C and M. So the meaning is, if you divide C and M by D, then the greatest common divisor of that two numbers should be 1. So the meaning is, if you compare C over D and N over D, there is no common divisors except 1, right? So still M over D is a divisor of this whole thing, then it should be a divisor of A minus B because there is no common divisor with C over D. So that's the conclusion we have. Once again, it's M over D is a divisor of A minus B, which means A is congruent to B modular M over D. That's how we got this result.